Elemental sulphur. We supply elemental sulphur and we also supply an alternative form of sulphur, sulphate. Sulphate is present in superphosphate, in ammonium sulphate and some other sulphate products. So they are generally water soluble. They are relatively immediately available to plants once you apply it to the soil. But the downside in some circumstances is that some soils cannot hang on to that sulphate sulphur against drainage or leaching of water down through the soil profile. And so those soils, those sedimentary soils which have a anion storage capacity less than 50 to 60% and have about 1,500 plus millimetres of rainfall plus irrigation a year are likely to require some form of slow release sulphur in addition to the sulphate sulphur that is added in superphosphate or whatever. The two products that we have are sulphur superphosphates at various concentrations of elemental sulphur added to the superphosphate as molten material, and a product called sulphur-90, which is finely ground elemental sulphur with some bentonite clay, which is an expanding clay, and they're in nice pastures. When you chuck it on the ground, the bentonite clay expands and goes poof, and away the elemental sulphur gets distributed around the granule in the soil. 90 to 100% of the sulphur, elemental sulphur that's added should be turned into plant available sulphate sulphur within the 12 months of application. How does this happen? There's a bug in the soil called Thiobacillus thiooxidans, which uses sulphur as an energy source. It creates sulfuric acid around the elemental particles, and that dissociates the hydrogen and sulphate. The plant uses the sulphate, the hydrogen stays in the soil, so elemental sulphur will acidify your soil in a small way. So if you're using it quite regularly, you need to factor that into your liming strategy to counteract the acidity generated. On average, it's about 3 kilograms of good quality limestone for every kilogram of elemental sulphur you apply.